the circuit diagram that I finally made it at the very end of the entire thing, after I constructed everything, after I built everything. Right now I am in the editing process. So I'm editing the movies that I recorded. It appears necessary to make the circuit and present it. This is the rotary encoder with EKSP ATtiny44, and here is a small diagram, only the necessary pins. I've also included the third LED that I actually used on this last board. And this is the final circuit, and I hope it is clear enough which are the wires that are going into the Arduino for programming the chip, and which are the wires for the rotary encoder, pretty much data wires, that are going in from this circuit into this ATtiny, and ATtiny is computing these three wires. And then if you change your mind on something, you reprogram ATtiny through Arduino. And I'm powering everything. So this larger circuit and this ATtiny chip plus its output LEDs that you are seeing there, they are powered from the 5 volts and the ground pins of this Arduino, exactly those two pins that are showing into the Simulino, which is Arduino. Don't get confused, Simulino is actually Arduino, is not something else. It's just a component for the Proteus simulator that I'm working in here. So this is the circuit for doing all the rotary encoder stuff. This is the ATtiny microprocessor or microcontroller. This is its output. These are the in-circuit programming wires, and these are the data wires that this microcontroller is listening to them and outputting, processing them and outputting whatever the correct answer is needed. And these LEDs here, I changed their position exactly as it is right now in reality. Before they were inversed with this resistor, the place was changed, but I actually made it exactly as I'm having it on my board. Yeah, you see on my 3D view, from this red wire, which is power supply, is going through the resistor into that LED. And then on this big pad with the capacitor on it. So this is the pad here where the pin is residing. And another resistor to the positive rail, which is that one. Clear as mud? Okay, I also color coded the wires because it's nice to have them like that. It's a bit more clearer. This is it. This is all the circuit in its glory. All right, here is a very short video about this circuit where I model it in my favorite 3ds Max 3D environment, including all the wires and everything, and I just basically copied in reality. I checked and double checked and triple checked both circuits. I am combining two circuits here. Let me show you. This is the in-circuit serial programmer for the ATtiny44 using Arduino Uno. This is the setup of programming this chip using Arduino Uno in serial programmer. These are the wires. This is 10, 11, 12, and 13 pins of the Arduino, and you can see them here mentioned on the board, and then positive and negative. So 6 wires in total. And here are 2 test LEDs. Here is a capacitor, and this is the resistor for these 2 test LEDs. Here is the rotary encoder, and using that in serial programmer circuit to test if I have problems, if I can do it. So this is the setup that I had it until now. This is the test that I made until now. As you can see, this green wire and these 2 orange wires are disconnected from the Arduino board because originally I tested them on pin A0, A1, and A2 here in this sector. And after the program was good and I finalized the program and it was giving me what I wanted from the rotary encoder, the good results. After that, I loaded into this ATtiny through these 4 wires, are the same wires on pin 10, 11, 12, and 13. And I only linked here a couple of wires to this circuit to make the connection between the new ATtiny program that is commanding and listening to all this circuitry, what I'm having here. So before, with these wires, I was using Arduino to listen and to receive data from this circuit. So now I switched to this chip. Clear as mud? And here is a close view to actually see all the connections. These 2 resistors, this one and this one, they are coming from the pins of the rotary encoder here and here, and are going into the positive line through that wire. And this resistor is coming from this pin of the rotary encoder and is this LED through this wire, and this resistor is coming from this other pin through this LED into that wire. And this is the positive pin of the LED, and that is the positive pin of the LED through the negative pin of the LED. So the positive is surging through the LED into the negative pin of the rotary encoder. And here in the middle is the track that is connected to the negative rail through that middle pin of the rotary encoder. And here this yellow wire is for the button press, and also this brown wire is coming from the pin, is going there on this line. This green wire is disconnected, so this is positive pin of the LED into the negative pin of the LED through that resistor into the negative rail. Is not showing, and this capacitor is on the pin of the button and the negative rail, and this other pin of the button press is connected directly to positive there. So that's the setup I'm having. This image, I use it all the time for this EKSP in-circuit serial programmer pins for this ATtiny44, and also for the pin numbering in code, how they are used encode for the ATtiny44 are these gray ones here, and these other gray ones on this other side. And as you can see, starting with 0 here on pin 13, pin 1 on pin 12, 2, 3, 4, 5, 6, 7 on pin 6, and then it's jumping to pin 8 on pin 2, 9, 10, and 11. And it's a bit fucked up here, but I've only used these pins here and here for the these 2 pins for the circuit serial programmer, and these 2 pins and that pin, this. So all of these pins, I use them in my final version pretty much, plus this one and other 2 that are needed for in serial programmer, and that's it. And also power pins, pin 1 and pin 14. So this is what you are seeing here is a combination between these 2 boards, is a combination between these 2 circuits in circuit serial programmer. You can see it actually here. This is actually a picture. Let me actually go into the 3D view. You see, it's exactly as I showed you before, smaller here. So if I can, actually I can, to pin it there, to stay there, not move, not disappear on me. So as you can see, the numbering, the pins are exactly in this final version, in this 3D view. I put this 100 nanofarads exactly as you can see it here in the picture. I also used the same type of capacitor, not this SMD one in reality in the final version. These green LEDs are these test LEDs, is 0 and 2. So this is 0 and 2. And I also added 1. So 0, 1, 2. Compare with original board. In the middle is the push button, and these 2 in the margins are for rotary encoder for the rotation. And here is the rotary encoder circuit that I link it exactly as I'm having it here on the breadboard. So I copied what I'm having on the breadboard, and I made a circuit here, and I link it to this ATtiny pins pretty much. Following the same logic what I'm having there, I checked, double checked, and triple checked to be sure the wiring is correct. And it worked from the first try, actually, with a tiny little bit of shitty error that had nothing to do with the tracks and the wiring. But beside that shitty error, it worked from the first try. Also, the 3D version, what you are seeing here, it helped me immensely, especially the wiring, to use the correct distances between all these pads, the boards, the components. The wiring, it told me how large I should make the board. So you see, originally I started with this size of the board, and I was putting all these wires that you're seeing them here in the air. I was putting them on the side like I'm having these red wires. You see them here. Then I decided I should make this board a little bit longer or bigger, and also I had to all this entire area to bring it back, and I've added this extra space there. These are the first versions of the circuit, and they have a tiny little bit of differences between them. They are a bit different, but here I realized I need that EXP to actually program the chip, and under it I'm having both of them. Under them I'm having this board with the chip. So that's how I planned originally to make it very, very small, and it was very small, but this is a prototype. At least for me it is a prototype. So I decided that being visible and being easy to repair and to visualize what the hell I'm having there and not to make mistakes or having errors, is better to see it and to have it like this, exposed, everything with the face up, not with complicated and elusive stuff that I'm having underneath, and very hard to get into it if I'm having any kind of problem. The design is very nice, I really like it, but it's not really practical, at least from prototyping point of view. But after this prototype is finished, I will consider to probably to remake this circuit sometime in the future and make it as compact as I can using this shape what I'm having here, probably. But it's not a certainty, it's just an idea. So that's it for the 3D presentation of the circuit in all its glory. I hope you like it. Thank you very much. That's it. You remember this board that I find it on the internet, and this was the inspiration for this project that I just finished, and I made it work. Granted, this board is very small, it's very compact, it's very well done, the bottom side of it. This is very well made compared with what I'm having. But from the functional point of view, I pretty much made this board, but in my version. This component that I took it under my wing, and I consider it a project for myself. Right now it is made and it is done. It is created. It is functional. Although it's a bit more different and more bigger than this board, technically it is the same thing. It's doing the same job as this commercial board for $25. While my board is quite cheap to do it, to make it. So pretty much what I made in this project is a driver. So this microcontroller ATtiny44A is used as a driver specifically for decoding the rotary encoder bit pattern. And this was all the project about. This was the entire idea that drove me to make it. And I still consider this commercial version quite a good idea to have and to use. So this is how it's working. When I'm rotating left, it's lighting up this LED, and when I'm rotating right, it's lighting up this LED. And now I will do it slowly to actually see the sequence, the binary sequence. You can see it in these two red LEDs. So first this one, second that one, but it will also lit up briefly this blue LED. You see? So that's the second. Now it will turn off this, and finally it will turn off that one. And this is the sequence. 1, 2, 3, 4. And in the other direction is the same thing. 1, 2, 3, 4. But right now it lit up this other LED that is telling us it's in other direction. So now it will lit up only in the right direction. And now if I'm turning it that way, it will lit up only this LED. And if I'm pressing the button, it will lit up this middle one. Like I said, this LED here is linked electronically to this button on the Rotary Encoder. It is instantaneously responding like that, while this other one is having some sort of delay. It is the programmed LED that you can change it in code. So that's the difference from these two LEDs. And as well, these red LEDs are electronically linked to the Rotary Encoder, while the blue LEDs here and that one are programmatically responding. They are responding from the program. The chip is executing the program and is decoding that binary sequence and is outputting these two LEDs. That's it.